Good morning. Today we are going to see how to solve a combination circuit between series and parallel resistance. So we have here our initial circuit. We have for a resistor with a different combination of series and parallel. So the step one, we are going to calculate the resistance equivalent to 3. 2 and 3 resistors are in series, so the equivalent is the sum of both of them. So the result is going to be 5 ohms. In the step 2, we are going to calculate the resistance 2, 3, 4. Is the combination between resistance 2, 3 and resistance 4, both in parallel. So we must do these operations so we can see 1 over resistance 2, 3, 4 is equal to 1 over 5 plus 1 over 5. So resistance 2, 3, 4 is going to be 5 over 2. So the result is 2.5 ohms. Okay. In this point, we can calculate the different values of voltage, current, and equivalent resistance of our circuit. So, resistance equivalent. Now we have in this point two resistance in series, so the equivalent resistance is the sum of both of them. 2 plus 2.5, 4.5 ohms. And applying the ohms formula, we can calculate the current. Is going to be the division between voltage and resistance. So it's going to be 2.67 amps. Okay? Well, we are continue calculating the elements: voltage 1, voltage 2, voltage 3, voltage 4, intensity 1, 2, 3, and 4. And now the method is the reverse, consists in reversing the circuit. In the last part, we tried to make the circuit smaller, trying to condense, and now we have to expand it, the circuit. I'm going to show you. Now, step 3, we have two resistance, R1, R2, 3, 4. This is our battery voltage. And if you remember, in series circuits, always the intensity is the same. So current 1 and current 2, 3, 4 is going to be 2.67 amps. But the voltage is different. And the addition of voltage 1 and voltage 2, 3, 4 is going to be 12 volts. So, voltage 1, if we apply the ohms formula, voltage 1 is going to be the resistance value, and the multiplied by the current value in the resistor. So it's going to be 5.34 volts. And in resistance 2, 3, 4, the voltage is the difference between 12 and 5.34 volts. So we have now the enough information to fill in this voltage 1 and intensity 1. Okay, now we are in the step 4. We are going to reverse the entire circuit. If you remember, this resistance is the result of calculate this the equivalent resistance between R23 and R4. The resistance 23 and resistance 4. Okay, so both are in parallel. So the voltage is the same in both 6.66, but the intensity current is different. It's different, I mean, it's going to be the sum of this intensity and this is going to be 2.67 amperes. So, how to calculate? Easy. If you remember, intensity 4 is going to be voltage divided by resistance, 1.33 amperes. The same in resistance 2.3. You can see a detail so more or less curious, but if you see intensity 4, intensity 2, 3 has the same value. Why? Because the value of the resistance are equal, so also must be the intensity current. Okay, and the last step is to go to the initial circuit finally. We are now in this point and we reverse the chains to resistance 2, 3, resistance 2, resistance 3. Both are in series, so the intensity current are must be the same and this value. The difference is now in the voltage 2 and voltage 3. Applying the Ohm's law, you can calculate both values. And finally, with all this calculation, you must fill in this table, okay? So, try to copy this exercise in your notebook, please. And also, today, I'm going to upload some exercises in the virtual classroom. And you must start today and continue tomorrow. When you finish these exercises, you must send me to my email account, okay? Please, this task is for today and for tomorrow, this week. Next week, we are going to start the next unit. And I will explain what are going to do for it. But this week, we are continuing with circuits and in special the combination circuit between parallel and series. See you. Goodbye.